The relational data model was introduced by C.F. Codd in 1970. Currently, it is the most widely used data model. The relational model has provided the basis for research on the theory of data, relationship, constraint, numerous database design methodologies, the standard database access language called Structured Query Language or SQL, and almost all modern commercial database management systems. Furthermore, the relational data model describes the world as a collection of interrelated relations or tables. Now let's talk about the fundamental concepts in the relational data model. A relation, also known as a table or file, is a subset of the Cartesian product of a list of domains characterized by a name, and within a table, each row represents a group of related data values. A row or record is also known as a tuple. The columns in a table is a field and is also referred to as an attribute. You can also think of it this way. An attribute is used to define the record, and a record contains a set of attributes. The steps I'm about to mention outline the logic between a relation and its domains. Given n domains are denoted by d1, d2, up until dn, and R is a relation defined on these domains, then R has some or all elements of d1, xd2, x, up until xdn. Now let's talk about tables. A database is composed of multiple tables, and each table holds the data. And then we talk about columns. A database stores pieces of information or facts in an organized way. Understanding how to use and get the most out of databases requires us to understand that method of organization. The principal storage units are called columns or fields or attributes. These house the basic components of data into which your content can be broken down. When deciding which fields to create, you need to think generically about your information. For example, drawing out the common components of the information that you will store in the database and avoiding the specifics that distinguish one item from another. And then we move to domains. A domain is the original set of atomic values used to model data. By atomic value, we mean that each value in the domain is indivisible as far as the relational model is concerned. For example, the domain of marital status has a set of possibilities: married, single, divorced. The domain of shift has the set of all possible days: Monday, Tuesday, Wednesday, etc. The domain of salary is the set of all floating point numbers greater than 0 and less than 200,000. The domain of first name is the set of character strings that represents names of people. In summary, a domain is a set of acceptable values that a column is allowed to contain. This is based on various properties and the data type for the column. We will discuss data types in another chapter. And now we move to records. Just as the content of any one document or item needs to be broken down into its constituent bits of data for storage in the fields, the link between them also needs to be available so that they can be reconstituted into their whole form. Records allow us to do this. Records contain fields that are related, such as a customer or an employee. As noted earlier, a tuple is another term used for record. Fields can hold a range of different sorts of data. This one has a record ID field. This is an ordinal number. Its data type is an integer. A pubdate field. This is displayed as day/month/year. Its data type is date. An author field. This is displayed as initial, surname. Its data type is text. And a title field text. Free text can be entered here. You can command the database to sift through its data and organize it in a particular way. For example, you can request that a selection of records be limited by date. That is, number 1, all before a given date. Number 2, all after a given date. Or number 3, all between two given dates. Similarly, you can choose to have records sorted by date. Because the field or record containing the data is set up as a date field, the database reads the information in the date field not just as numbers separated by slashes, but rather as dates that must be ordered according to a calendar system. Degree. The degree is the number of attributes in a table. Okay, now let's talk about the properties of a table. A table has a name that is distinct from all other tables in the database. There are no duplicate rows. Each row is distinct. Entries in columns are atomic. The table does not contain repeating groups or multi-valued attributes. Entries from columns are from the same domain based on their data type, including number, like numeric, integer, float, or small integer, character, string, date, logical, like true or false. Operations combining different data types are disallowed. Each attribute has a distinct name, and the sequence of columns is insignificant. The sequence of rows as well is insignificant. Now let's talk about the types of data models. High-level conceptual data models. High-level conceptual data models provide concepts for presenting data in ways that are close to the way people perceive data. A typical example is the entity relationship model, which uses main concepts like entities, attributes, and relationships. An entity represents a real-world object such as an employee or a project. The entity has attributes that represent properties such as an employee's name, address, and birth date. A relationship represents an association among entities. For example, an employee works on many projects. A relationship exists between the employee and each project. Record-based logical data models. Record-based logical data models provide concepts users can understand but are not too far away from the way data is stored in the computer. 3 well-known data models of this type are relational data models, network data models, and hierarchical data models. The relational model represents data as relations or tables. For example, in the membership system at Science World, each membership has many members. The membership identifier, expiry date, and address information are fields in the membership. The members are individuals such as Mickey, Minnie, Mighty, Door, Tom, King, Man, and Moose. Each record is said to be an instance of the membership table. The network model represents data as record types. This model also represents a limited type of one-to-many relationship called a set type.